Alright, so we're on the road to 10 gig networking now. In my hand I have the Intel X540T2 dual copper NIC. This is going to go in the Unraid server. We have the Action 10 gig NIC. This is going to go in the truncator. And to fully saturate the 10 gig NICs, we're going to need some high performance SSDs. Specifically these Toshiba Nvme SSDs. I've had these for a long time now. And that, yeah, I don't know. So they're going to be the new cache drives on our Unraid server. And in order to install those, we're going to need this Hyper M.2 expansion card. So, without any further waiting, let's go ahead and jump right on in. Now, before we turn the Unraid server off, we're actually going to have to invoke the mover. So I've already enabled it now, so it is moving everything that's on the cache to the array. Once we do that, we can turn off Unraid, replace those two Intel SSDs right here with the Toshiba Nvme drives. Alright, while we wait, we'll just open this stuff up. So like again, this is the Intel X540T2. I don't know if you guys can see that, but it is an Intel genuine component. You can tell because it has the Intel markings all over it, which is pretty important. So if you do buy this from Amazon, it is not the exact same thing. We got very fortunate to get one of these on the cheap. Now the Action 10 gig NICs, these are like $78, so well under $100 now for anyone that's looking to move to 10 gig at home. And it's a pretty simple copper-based NIC as well, nothing fancy. There is a pro version of this which comes with free software and I think a black PCB and maybe a different heatsink. But honestly, who cares about that? It's going to be inside a computer that we're barely going to see anyway. And it does also come with a short PCI bracket or whatever. So if you need that, that option is available. And finally, we have the M2, or Asis M.2 expansion card. Not really much to this thing. I don't think this thing is surprisingly heavy. It's pretty awesome. And yeah, that's it. So this holds 4 PCIe NVMe drives, M.2 M key to be specific, which is really hard to find. I don't remember how much you got this for, but I think it was $170. It's got a little blower fan here, and this is an aluminium heatsink, or I don't know, whatever you want to call it, but we'll call it a heatsink for now. So I'm not entirely sure if we have to remove the bracket or not, but we're going to leave it on there and see what happens. Okay, so that just pops right off. This is the inside of the card, all black, your 4 spaces for your NVMe drives. Oh, and cool, it has like, I guess some heat spreader sticky pads here. So it looks like if you peel those off, you can get them strapped to your actual NVMe SSDs. We'll go through that eventually, but I guess it'll sit something like this, or maybe like this, one of the two. So it'll help get some thermal conductivity between, your NVMe SSD and the heat sink itself. And it's really cool about this product is it does have a blower style fan here, which will be nice to have, even though our NVMe SSDs don't get that hot. Alright, so while we're waiting for the mover to finish, we're going to go ahead and install the 10 gig NIC into the truncator. So this should be pretty simple and straightforward. We literally just have to slot this thing in. Oh, I probably should turn the power off just in case. I don't want to electrocute myself and or do anything bad. I'm confident I am discharged, and we're literally just going to slide this in. Pretty straightforward stuff. Or I think I can get it in. I'm having some difficulties here, much like I do in bed. Just cut to me having this installed. Alright, and just as easy as that, it is installed. And we're just gonna secure this down. And we're done. That's it. Now, I already have 10 gig, or I'm sorry, not 10 gig, but Cat 6 cable run. So all we have to do is just plug this BC in and we're off to the races. Now that the mover is finished, we have to do a few more things to make sure we don't lose any data from our cache disks. First, we go to Settings, and we're going to want to turn the mover scheduler to essentially off or a very long time for now. We'll just set it to monthly. And I'm hitting apply. Okay. Now we want to disable all virtual machines or turn off all virtual machines. So there's nothing important running on these. So for me, I can literally just say stop. Stop. Oh, I did force stop on that one, but that's okay. That one didn't turn off, so I'm going to do a force stop. Turn off auto start, just in case. Okay, they are stopped. And we're going to go to settings. VM manager, we're going to set this to no. Finally, for some reason it takes. So we're going to VM manager, enable VMs. We're going to set that to no. Okay, that worked that time. Hit apply. It appears to be thinking. Okay, it looks like it took that. You can already see the VMs has disappeared. Now we're going to go Docker. We're going to turn Plex off. Hope nobody was watching that because I just lost it. And we're going to stop auto start. Then we're going to settings and Docker. We're going to turn this off. Apply. And finally, we're going to move all of the shares to cache for some reason. The instructions are kind of strange on this one. So if we're reading here, it clearly says click on shares and set all shares present on your cache disk to use cache disk yes. This will cause the mover to move all shares off the cache drive. What a strange implementation. So Docker is now also gone, so let's go to shares. I have no idea where we're going to do that. I guess we have to go to each individual share and do that, so I guess I will do that. So after waiting a literal eternity, I can stop the array, which I just did, and power down the system. And now that it's about to be powered down, now it's about to be powered down, we can unrack the server and stick in our Nvme drives, and we'll be good to go. Alright, so now we just gotta pop this bad boy open. And what did I do with the card? Oh yeah. So, theoretically this should work because of pci-e bifurcation, which essentially splits, let's say this is a times 16, so it'll split each one of these NVMe drives in 4. Well, in this case, because I'm only using 2, it'll split this 16 by 8, so both NVMe SSDs will be essentially operating in a NVMe by 8 PCI lane. So as you can see, we already have the LSI card in the top slot, and we are going to stick the NVMe. Is this right? Is this lined up correctly? I don't know. This looks right. And then we're going to stick the NVMe expansion card one slot over from that. So that it's labeled times 16, so I'm just on the motherboard, so I'm just going to assume it's the 16 slot as well. Can I even get this in here? I appear to be stuck on something. What the hell am I stuck on? There we go. So now that's in. Batten down the hatches, and then we got to find a place for a 10 gig NIC. And it looks like there's actually a slot right here by the RAM. I'll see if I can give you a better look here in a second. Let me get this screwed in. So I was going to put the Intel NIC right here, but it's actually too big for that. So we are going to instead stick it right there. It should be a good spot for adequate airflow and work perfectly fine. So once we get this NIC in here, I think we'll be full up and not be able to really do anything else. Like, we might be able to stick another graphics card in here, but it won't operate at the full 16 capability. I'm not sure what it'll operate at. I'm not even sure what this NIC will operate at, but we'll do some testing and see what happens. So I guess we're done here. Alright, so we made a huge mess over here. Not a big deal. But theoretically, Transcendia should turn back on. And we'll find out here in a moment to see what happens. So in theory, this should be working now. Alright, and we're up. So that's a good sign. Let's see if we can see these drives. Okay, I only see one. That's interesting. I wonder why. Maybe it's seeing it as a RAID 0? Maybe the other one's not compatible. Maybe it's not getting power. But what's interesting about this is definitely the second one in the second slot. So maybe it's loose and needs to be reseated. I'm gonna guess that might be the issue. So we're gonna power down, derack it, and see if we can get it to show up. So before we test to see if it's working in the server, we're gonna boot it up in Windows and see if both drives can be discovered. If it can, then I know we're good. If it can't, then there's a deeper problem. So we need to figure that out. So we discovered that it doesn't work on the truncator, and it looks like because I only have one 16 rail and then two 14s left, which is really weird because I'm pretty sure I should have two 16s and a 4, but I'm willing to bet because I'm using PCI Express on one of the, or for the NVMe drive, it's taking away some of my lanes here. So we're going to pop out the NVMe, the onboard NVMe SSD, and see if I can get back some of my lanes and then see if it works. This is becoming a mess. So basically now I've got to remove all of this stuff in here to get to the NVMe drive, or maybe not all of it, but probably just the Titan. And once I do that, then we're going to turn this bad boy back on just to see if we can get a times 16 rail out of this, or not rails, 16 lanes out of this. And unfortunately, because the 5960X doesn't have onboard graphics, I can't just use an alternative source. I have to use this Titan, which is going to consume 16 of those lanes. So got that, and now we just need to remove the 960 Evo out of here, which I apparently can't do with that. Okay. And back in you go, Titan. Now, in theory, this should work. Alright, so this Titan's gonna need some support. It's sagging pretty hard here. Wow, really? You're just gonna fall out? Anyway, so this Titan is sagging pretty hard here, and it looks like I'm having some difficulty. Something is blocking it. What is going on? Alright, so we're booted back up, and there's still no change. I'm showing us 16 lanes on the first PCI Express slot, and PCI Express slot 2, I'm still showing 4. So I'm guessing that motherboard actually doesn't have two PCI 16 lane slots, as it says it does. So now we gotta figure out what we can do from here. This is getting really shitty really fast. So interesting turn of events. We moved, let's see if we can see in here for a quick second. Alright, so we moved the adapter up a lane, so that is in the top slot, so that should be theoretically a 16 lane slot, and it's still showing up as 4. So something's not right, and we got to figure out why this is only showing up as 4 lanes, or only giving me 4 lanes. So I'm going to play around with the BIOS a little bit and see what we can get, if anything. Now things are getting interesting. We have this propped up on my chair. If we swivel around to the rear, I've got this hooked up to the wall, and the TV hooked up to the wall, and also to the server itself. And now we're going to power it on and see if we can get into the BIOS, and maybe see if there's like some fancy setting I could turn on to allow all lanes to appear to the server. I'm getting real worried now. The server's not booting up. I'm getting error code of 60, which is kind of weird because it's been working perfectly fine for a while. This may not be worth it. I'm getting kind of scared. Okay, so we're in the advanced CPU settings, we're in the Northbridge configuration, something called IOH, and in here I can actually see what speeds or link widths the PCIe lanes are operating at. Interesting to note, 3 and 4 are together, and PCIe lane 3 is empty, and PCIe lane 4 is actually occupied with our NVMe SSD. So I can split this up by 8x8 or 4x4x4. That's 16. This is 16, and 16 obviously as well. So we're actually going to set it to 8x8 instead of auto, and we're going to set this to Gen 3 instead of Gen 2. Now, I don't know if that's going to help, but we'll find out. And so PCI lane 5 is the HBA card, and in 2 is the, what is in 2? I'm looking here. Oh, and 2 is the HBA card itself. Or wait, did I get that right? Yes. No. 2 is the Intel NIC. Yeah, 2 is the NIC. 3 and, well, technically not 3 and 4, but 4 is the NVMe SSDs, and PCIe 5 is the HBA card. So this looks right. So now we're going to, I don't even know what this stuff is. We're just going to get out of here for now. We're going to save these settings. Actually, let's see if we can see them in here before we even bother trying to boot. Oh man, boot options, SanDisk. What is this? IBA? I don't think we'll be able to see those in here. Hardware monitor, maybe. No, this is just the fans. Wow, this is going incredibly slow. Oh, no. It won't be in storage. Yeah, that's great. We'll just save. Boot. Security. We'll just save changes and see what happens. So after making that change, we can now see that there's 2 NVMe SSDs. So it looks like that worked. And now we can just reboot this, or power it down actually, and get it re-racked, and we should be done. Well, mostly done. So right now I am copying over the system, app data, and domains folders back over to the cache. The reason for that is because those folders store information that is needed for Unraid to work as it did when we moved everything off of the cache and into the array. So I'm not sure how long this is going to take, but I've been sitting here for already, 20 minutes, and it's still not done copying over. So we'll just have to sit and wait and see what happens. Okay, after rebooting the array, there's a couple things I wanted to check, and that was to make sure that VMs were enabled, and we can already tell VMs are enabled, and also Docker is enabled. And actually, yeah, it looks like the Plex is there still, which is good. And our VMs are obviously still here. We can see that I have my host name now that the copy is done. So it looks like we're good to go. There are a couple of things I want to test, and the first of which is, I guess, to launch these and make sure that they work. Docker, they sure did boot really quickly, which is always great to see. Much quicker than usual. And now we're gonna hop over to Windows and see if we can get our 10 gig throughput here. Let's switch back here to public real quick. I just wanna, or plugins, not plugins. Settings real quick, and what am I doing? Docker, wow. And turn auto start on for this as well. I guess save, oh, that's weird. All right, let's see what happens. All right, so we just verified that all the data from the old cache SSDs has now been moved to the new SSDs and seems to be working. So ultimately what needs to happen is the truncator needs to get internet and also be able to connect to the server. We don't have a 10 gig switch, so we're gonna have to bridge the server NIC and the onboard NICs together so we can get internet to the truncator. So what essentially that's gonna look like is internet's gonna come into the modem, of course, and it's gonna go to the switch, and then from the switch, internet is then gonna go to Transcentia itself. And of course, Transcentia is gonna have a bridged connection, or maybe not connection, but is gonna have a bridge set up between the 10 gig NIC and the onboard NICs to allow internet to get to the truncator. And then also, we'll be able to transfer everything really quickly, all those video files, any files, any large files, really quickly to the truncator from here via that 10 gig NIC. And then of course from the 10 gig NIC, we're gonna go all the way along the wall here and then to the truncator and then back to the 10 gig NIC. So 10 gig NICs on both sides along this wall. And no, I'm not trying to show off. I am trying to do some cable training, and that's why all this stuff is kind of laid out like that, because I needed stuff to weigh the cables down to keep them in place so they'll be nice and straight when I remove all this eventually. So what we're gonna wanna do now is go into settings, network settings, and once we're in the network settings, we're going to want to make sure that we've added, if I can see this, it doesn't look like it's going to let me see. Come on. Oh, well, it doesn't look like it's going to let me see, but you'll have to take my word that, oh, here we go. So ETH4 and ETH5 are added. So ETH4 and ETH5 are in fact my 10 gig NIC. I know this because, well, these already existed on the onboard NICs, and they have the same MAC addresses, whereas the 10 gig NICs have different MAC addresses from the onboard NICs. So we have a pretty high level of confidence that these are the 10 gig NICs. And what's very important here is that we want to make sure that enable bridging is set to true. And then we added all of those to the bridging members, all those NICs, or Ethernet ports, whatever you want to call them. All of those are part of this bridge. What we've also done is set a static IP address, and I did this because I want my server to have the same IP address every time it boots up. So that is that there. And I set the default gateway to the actual router itself. This is kind of important, I think. I always do it, and things seem to work out. And then really, not really as important, but I did it anyway. The DNS server is also the router, which is the same IP address. And then we have a couple backups here to Google. And that's pretty much it from the Unraid side. And on the Windows side, I already hit apply, and the array is already running. On the Windows side, it's already working, and we can check that out here in a second. So it's important to note here is that this should immediately say that it's connected. But what we want to do is double check that it does in fact have internet connectivity. In this case it does. We can see that it's running at 10 gigabit per second. We can go details. We see it's pulled an IP address already. It's in fact seeing the DHCP, default gateway, and all that stuff. And now if we check, we can actually confirm that we can hit YouTube or the internet. And there we go. So we'll close that out. Now, if you at home are having trouble connecting to the internet, one thing you could do is check the properties. Go to IPv4, properties again, and you may need to set the preferred DNS here to your local router or DNS server, whatever the case may be. And that should allow you quick access to the internet itself. I'm also already connected to the server by IP address. I did this on purpose because I wanted to make sure that it would connect via IP address and not host name. I don't know if it matters, but I don't know, just in case. It made me feel good on the inside. So what we're gonna do is we're just gonna copy a video from one SSD and drop that on the file share. And we're getting better than gigabit, but not really. Not sure why that is. It's very strange. So we are not maxing out the Nvme drives either. The server could be busy doing something. I'm not entirely sure. But we will let this finish and we'll try again. So somehow during troubleshooting, Plex got broken. I have no idea why it's not working now. I've gone through the configurations. I've installed it and reinstalled the Docker for Plex, and it just, no luck. So I'm not really sure what's going on there. But during part of my troubleshooting, I did come across some other users having problems getting full throughput with their SSDs, and we may have learned that these SSDs actually are not that fast, or well, they're fast initially, but not in the long run, and I'll show you what I mean. So this script here was written to show us the quality of the hard drive or SSD, or basically can show us how fast these SSDs write. So we see here, when it's a very small file size, it writes at about 283 megabytes per second, which is pretty good for an SSD, but these are supposed to be NVMe SSDs, so this should be really fast. And then one thing you'll notice is that as the file size gets bigger, the write speeds get slower, which is probably part of our problem here. And then now what we're going to see is that the buffer on the actual SSD should run out of space and the speeds get slower. Now, I haven't always been able to make it consistently happen, but when we're pushing around those 20 gigabyte files, the SSD itself just runs out of cache, and that's why our speeds seem to be tanking, which is really interesting. So I'm not sure what I'm gonna do, but I do have a couple of ideas. I do want to test some of my SSDs that are laying around and see what they're capable of, and see which ones may or may not be better. So I guess that's what we're gonna do next, because if the SSDs end up being better, then we'll definitely do that. So this is obviously gonna complete, but yeah, I'm just not, those write speeds are pretty slow. So I guess we're gonna try and figure out what we can do from here. So it turns out the file transfers are pretty impressive, at least at first, when I get about 500 megabytes per second. But the sustained writes are actually pretty poor, I would say. I average, or I shouldn't say average, but it fluctuates between 200 to maybe 332 megabytes per second tops, which is actually really good, but not quite what I was hoping for. So what I'm doing is running benchmarks on every single one of my SSDs to see how they stack up against each other. So originally, the 530 SSDs were in the truncator, and those were the cache. And the game plan was to upgrade this to 1 terabyte NVMe Toshiba drives. But the performance is not so good when you start getting files that are 20 to 30 gigabytes in file size. In order to really compare it, I need to see what these are capable of, because I already ripped them out. And I also want to take a look at my Intel 730s, because they've kind of been sitting around collecting dust since I've moved to NVMe storage. And I want to see which of these drives has the best sustainable write speeds over a long period of time. That's going to be really important to me because I work with really large file sizes. Right now I am benchmarking the 960 Pro, and it's looking really good. That's expected. And we're doing that with like a 5-minute write time of a 32 gigabyte file. And it looks great. If that really looks like the best thing, and I'm sure it's going to be, we may consider buying maybe like a 250 gig 970, but I'd really like a larger SSD, and that was the whole point of moving to these Toshiba 1 terabytes. And so my cache is really large because I work with so many large files. And the 250s, they fill up really quickly, and I have to initiate the mover all of the time on Transcentia, or Unraid, whatever you guys want to call it. So I guess we'll see what happens from there. I wouldn't mind a 500 gigabyte. This is 480, and this is only 240, which is the whole reason why I got rid of this. But I want to know anyway, just in case, so I can figure out if I need to buy something or if I can just live with these. Or maybe I could just live with these. And we won't know until we benchmark. Well, we'll have a better idea because the benchmarks aren't necessarily perfect, but they'll get me right in a range of operation that I will, understand that I'll be within like a plus 5% or plus or minus 5% range of where the benchmark produces. So now we wait. And to no surprise to anyone, obviously the 960 Pro was the fastest in every regard to the entire group of SSDs we tested. Next up was, of course, the Nvme Toshiba drive. It looks like it gave us a speed of 983 megabytes per second. And that's sustained writing, which is pretty important. So that means we'll probably be able to hit that 1 gigabyte per second threshold, at least for a little while anyway. The problem that I was seeing is I was not hitting that. I would immediately dive down to 400 megabytes or 300, whatever it was. So we have to kind of troubleshoot some more and see what's going on there. But next up was the 730, of course, and then finally the 530, this one obviously being the worst. And this one did surprisingly well. It was just slightly slower than the Nvme drive in almost all the tests. Okay, maybe that's not true at all. It was pretty significantly slower in most regards. But for a SATA connection, this is by far the fastest thing I have, at least SATA-wise. And I was really impressed with its overall performance, and I still might want to go to this, because then I'll have a RAID 1 capability. Well, I guess I'll have RAID 1 either way. It doesn't really matter. So I guess we're going to go with the Toshiba drives, and we're just going to have to figure out what the hell is going on. Because for the life of me, I just don't know. So back to the drawing board. So things have gotten pretty bad. I've been spending the last few days, 5-6 days, I don't even remember at this point, troubleshooting issues between Unraid and Windows and drivers and hardware, whatever it is, and we haven't really gotten anywhere successful. My Docker ended up breaking during some troubleshooting, or not my Docker, but my Dockers, like Plex and some of the other ones I run, just stopped working, inaccessible, so I decided I would do a clean install of Unraid, and we've moved to 6.6, and sure enough, Plex, the web UI, is still inaccessible, and I'm having some other issues that I'm kind of working through at this time. But I think I have the hardware I wanted after the benchmarks that we did, and now I'm going to do my final test of transferring this 9 gigabyte file over to the server with the hardware it has, and that will just have to be good enough until a later date. So let's just see what happens. And no matter what, I'm going to try and be happy, even though I'm not getting my 1 gigabit per second. All right, here we go. Going to make the transfer now, and we'll see what happens. Oh my God. Oh, 942 megabytes per second. Who would have thought at the very end we finally hit 900 megabytes per second? Wow. I literally did not think this was going to happen. I was preparing myself to be very, very butthurt. And it's working. Oh, wow. How cool. Yeah, I'm out of words. I don't know what to say. Alright, so that was a pretty fun adventure. It took a very long time to get everything working correctly, at least the way I wanted it to. So if you guys are interested in kind of following suit, or at least using some of the things I did, you'll find links in the description below for these items. I'm not going to include the Intel NIC because I picked that off of a local pickup, whatever. I picked that up locally. However, I'll link the one in Amazon. I don't really want to do that one because that one's on a true Intel NIC, but I haven't heard too many reports of it not working with Intel drivers. Supposedly you can put Intel drivers on that. So that'll be included too if you're interested. And yeah, thanks for watching, and see you guys next time.